In this module, we will learn the basic instructions of the S7-1200 PLC and their applications. We will also undertake a specific task, designing and simulating an intelligent traffic light control system, and master the practical application of these instructions. This task will involve important concepts such as comparison instructions and timer instructions. Through detailed analysis and design processes, we will gain a deep understanding of the important role comparison instructions play in PLC control. Red, green, and yellow traffic signal lights are installed in the east, west, south, and north directions of a city intersection. For traffic safety, the red, green, and yellow lights must illuminate alternately according to a specific sequence. The specific control requirements are: when the start button is pressed, the signal light system begins operation. When it is necessary to stop the signal light system, we just need to press the stop button. The normal sequence for the signal lights is as follows. First, when the signal light system starts, the north-south red light turns on first. Simultaneously, the east-west green light turns on. Second, the north-south red light remains on for 25 seconds. While the north-south red light is on, the east-west green light also remains on for 20 seconds. At the 20-second mark, the east-west green light begins to flash. The green light flashing cycle is 1 second, meaning it is on for 0.5 seconds and off for 0.5 seconds. After flashing for 3 seconds, the green light turns off. The east-west yellow light turns on and remains on for 2 seconds. At the 2-second mark, the east-west red light turns on, while the north-south red light turns off, and the north-south green light turns on. Third, the east-west red light remains on for 30 seconds. The north-south green light remains on for 25 seconds. At the 25-second mark, the north-south green light flashes for 3 seconds and then turns off. The north-south yellow light turns on and remains on for 2 seconds. At the 2-second mark, the north-south yellow light turns off and the north-south red light turns on. Simultaneously, the east-west red light turns off and the east-west green light turns on. This begins the second cycle of operation. Fourth, the sequence repeats cyclically thereafter, until the stop button is pressed. The objectives of this task are: first, knowledge objectives. 1.1 Master the instruction format and function of comparison instructions. 1.2 Understand the differences between integer and floating point comparisons. 1.3 Master the application strategies of comparison instructions in sequence control. Second, skill objectives. 2.1 Be able to correctly configure comparison instruction parameters. 2.2 Be able to achieve coordinated control using timers and comparison instructions. 2.3 Be able to perform composite judgments involving multiple logical conditions. Third, competency objectives. 3.1 Cultivate awareness of industrial safety standards. 3.2 Enhance fault diagnosis and debugging capabilities. 3.3 Strengthen systematic engineering thinking. Now that we have the task objectives, let's see what knowledge we need to prepare to better complete the task. Comparison instructions are the core components for implementing logical judgments in PLC programs. The essence is to perform an arithmetic comparison of two operands and change the logical state based on the comparison result. In the S7-1200 PLC, these instructions perform numerical comparisons using 2's complement representation. Common comparison instructions include 6 types in total: equal to, not equal to, greater than or equal to, less than or equal to, greater than, and less than. Value in range, value out of range. Check 4 types of variable comparison instructions such as validity and invalidity. Equal to and not equal to instructions. Used to determine if the first comparison value, operand 1, is equal to or not equal to the second comparison value, operand 2. If the comparison condition is met, the instruction returns an RLO, result of logic operation, of 1. If the comparison condition is not met, the instruction returns an RLO of 0. The RLO of this instruction is logically combined with the RLO of the entire network as follows. When comparison instructions are connected in series, an AND operation is performed. When connected in parallel, an OR operation is performed. The first comparison value is specified in the operand placeholder above the instruction. The second comparison value is specified in the operand placeholder below the instruction. If IEC check is enabled, the operands to be compared must belong to the same data type. If IEC check is not enabled, the operands must have the same width. Furthermore, if two variables have the same structured data type, the values of these two structured operands can be compared. The use of the four instructions greater than or equal to, less than or equal to, greater than, less than, is basically the same as the equal to and not equal to instructions described earlier, except they cannot compare the values of structured operands. Other parameters are as shown in the table. With the above knowledge prepared, we can now proceed to the task implementation phase. Based on the task description, we can draw a flowchart for the task. From the flowchart, we can analyze that one complete execution cycle of the task takes 60 seconds. Then it continuously cycles until the stop button is pressed. Based on the input and output devices we need to control, we set up the I or O assignment table for the PLC controlling the traffic lights, and use the most common self-latching program to implement system start and stop. Based on the conclusion of a single 60-second cycle, use an on-delay timer instruction to obtain an accumulated time parameter, MD4. In the running state, compare this accumulated time parameter with the required times from the task to implement the functions of each traffic light. For example, the north-south red light turns on when the accumulated time MD4 is less than or equal to 25 seconds or greater than 55 seconds. At this point, the programming for the intelligent traffic light control system is complete. After programming, proceed with operation debugging. First, with power off, connect the communication cable. Second, on the PC acting as the programmer, run the TIA Portal programming software. Third, create a new project and perform device configuration. Fourth, open the program editor and enter the ladder logic program. Fifth, click to execute the compile command under the edit menu to compile the program. Sixth, download the control program to the PLC. Seventh, design the HMI screen and download the configuration project to the touch panel. Eighth, set the operation mode selector to the run position, or click the run button on the toolbar to put the PLC into run mode. Ninth, observe whether the indicator lights turn on and off correctly. The reliability of comparison instructions depends on three key elements: correct data type handling, reasonable setting of comparison margins, and rigorous design of trigger conditions. Comparison instructions are the core tool for sequence control. Combining different comparison methods enables complex logic. Comparison instructions act like the decision-making brain of industrial control. Accurate judgment is the foundation for achieving intelligent control. Mastering the essence of their application enables one to handle automation with ease. Students can consider the following questions. First, how could variable cycle control be implemented in this task? Second, how could a countdown display be implemented using comparison instructions? Here is an extended task for students to complete after class.